We're going to start off with Bridgestone and Tavant sharing the early warning scout, and then 3 people from will be in the second group at 2:30, which is going to be hosted by Toyota and Upstream. Paul Mortimer from Upstream is going to be joining in that conversation as well. But I'm going to hand it over now to James and Petchy so that they can take over their portion of the presentation. And James, you can go ahead and share your slide as well.
Take a few minutes to cover, and maybe you guys can let me know if you can see the slide that we'll be building here. Hopefully you can. What I wanted to take a few minutes to cover is the challenges that we have in terms of the what and how we do with early warning. And so what you see in front of you is just a simple timeline, right? So we're starting this timeline. And the very first thing that happens, let's see if I can get this to advance. And this is not specific to tires. This is just a discussion about everything, right? There is some condition that materializes. Something happens. And that is the starting point of early warning, right? This thing happened. And it's very early. And the issue is that I don't know anything about it. I don't even know it happened. And that's why it's coded here in red, is it happened. So that's the starting point to early warning. We'll cover something else on that in a little bit. So then the next thing is, okay, is the owner operator aware that something happened? Because that's really the next step here to make others aware is, you know, the person who's dealing with it has to be aware. And so we're still red. We're still very, very early in the process. Nobody knows this happened. Maybe the owner knows, right? If the owner does know, they're going to take this forward and they're going to say, okay, I'm going to take it somewhere. I'm going to take it to a dealer. I'm going to take it to the manufacturer. I'm going to take it somewhere. And you see now, excuse me, as we move down the timeline, we're starting to get from red to green. So we're starting to get a little orange here. Okay, now we're involving other people. Now something is happening. But what happens if the owner's not aware? The owner doesn't know that there's a condition that's happened. Well, at some point, and let me see if I'll put a laser pointer in here. So at some point, you know, if the owner doesn't know, it takes the owner to become aware before we can move forward. And remember, time is passing here. Time is passing. It's happened. Now time passes. Now, at this point, I'm going to throw in a little wild card, right? There's a social media element of today. And so maybe the owner becomes aware and they talk about it online, or maybe the owner becomes aware and they're taking it to the shop and they're talking about their experience, right? So all of a sudden there's a little blip out here where there's some publicly available or some maybe not publicly, but there's some, I can mine some information that something happened to my product. So there's this social media piece, right? So now what happens? So I'm at the shop. Now the next part, okay, now somebody at the shop has to go, okay, is this something that the manufacturer wants to know about, right? Whether it's warrantable, whether it's a performance issue, so it says the word covered. It means that from a warranty perspective, is it really covered? But somebody at the shop is making a determination. And this determination is going to go one of two ways. Either somebody at the shop is going to say, yes, this is something that may be covered by warranty or maybe a performance issue. I want to make the manufacturer available, or not. Hey, the owner of this product, I'll just say tire, you know, the tire owner, the car owner, shop goes, nope, nah, you did this, best of luck, right? So now what happens? Well, If the determination is that, nope, this is not a covered condition, or this is not something we want to escalate, and then we're back to red. All of a sudden that data is unavailable to me anymore, right? So whatever it was that happened, whatever condition materialized, it's over. It ended. Maybe there's a social media piece here, but the manufacturer never hears anymore at this point. And of course, if it is a covered condition, it does get to the manufacturer through whatever channel that looks like, right? There's some data exchange, there's some correspondence, there's some communication. And so when you look at this timeline, you go, okay, you know, what's happened along the way? How long does it take to get here to where, as the manufacturer, you actually know that something happened, right? And at this point, you know, there's data collected, right? This timeline, it's not instantaneous. So from the time the condition materializes till the time the manufacturer knows that the condition materialized, is it a day? Is it a week? Is it a month? Is it a year? Is it never? And so that's the challenge from our perspective when it comes to early warning. So what we typically do is we have kind of three basic places that we're looking at to try and improve this early warning signal, right? I'll start here at the back, you know, around the data that's being collected, around how we collect it, whether it's transmitted to us electronically, whether it comes through some kind of telematics, whether whatever, how I can make sure that the whatever shop they took it to wants to play my reindeer games, right? They want to communicate data to me. So there's an entire effort around this back end that not only us but many manufacturers are looking at, right? How do we deal with this data piece? How do we get more data? How do we streamline the data? How do we use the data? There's a second area that needs to be looked at and can be looked at when you're talking about, you know, how is it that you do early warning? And that's right in here. It's this shop. It's this action. It's how do I get data that might be for conditions that aren't covered? How do I make sure that this path is a path that's solid to bring me information? And how do I make sure that the technicians and the service mechanics and whoever that's looking at it is actually making the right decision to tell me that something's going on? So here's another area, this area of what happens at the service location and how do I recover data, that there's another opportunity, and that, like we're even looking at, how do we get early warning signals out of this step in the process? And of course, the very first step in the process is from the time the condition materializes till the time the owner's aware, maybe the owner isn't aware. How do I get this red data? Because this is the earliest of early warning, right? There's a little extra step here that I'll add. Some of you might have been thinking about it already. What if I can actually understand that something is about to happen before it happens, right? I still don't know about it as the manufacturer, but how is it that I can look at this whole front step? This is the big space for us, is how do I get as close as possible to when the condition actually happens for me to get feedback, for me to get information, for me to potentially take action, for me to understand if it's even relevant for what I'm doing. And so that's kind of the third part that we're really looking at, is how to do this prediction, how to look for precursors, how to intervene to get information long before decisions are made downstream, and how to feed that into our systems and how to have the right tools, whether it involves AI, whether it involves telematics, whether it involves some social component. What does this look like? And so that's really all I wanted to kind of present and talk about in this little introduction to the rest of the presentation here. is this is what I'm faced with as a manufacturer, and some of you as manufacturers are faced with the same thing, is early warning is interesting, but if I'm only talking about doing early warning on a signal that's way down here, I'm missing all the rest of what could have happened. I'm missing data that never got to me. Time has elapsed, and time is critical. And I'm missing, how to make owners aware, how to make shops aware, so that the data that does come downstream can be better, both in terms of quality and in terms of quantity, so that I could do something with it. So any thoughts or questions on just kind of setting up the need for what is early warning and where are the areas where we're looking at an early warning? And I think this will be a good kind of primer for the discussion that's going to happen here with the others downstream.
I think it's a wonderful introduction, James. I think you painted exactly a right picture in terms of three bucketed items. When the manufacturer knows these issues, and you clearly articulated that it is way beyond. At least, to my knowledge, from an automotive industry perspective, from an EV vehicle perspective, I think the precondition, whether the owner is aware, there are some tractions going on, but not a whole lot, because the vehicles are connected and the OEM has an ability to look at and understand where exactly those issues are. But the second bucket that you talked about the information coming from dealers, the information coming from the distributors. There are some improvement needs to be done, because there are some work to be done between dealer and the OEM side in terms of sharing data. But it started happening. A lot of dealers started sending their repair order data to the OEM to start looking into this, or at least the OEM is putting an effort to buy this data from these dealers and distributors. I just wanted to paint a picture in terms of wanted to share how we are currently working with multiple OEMs on this space. Maybe Pam, if you can go to the second slide, and maybe can you make it a presentable mode, if you don't mind? Yep. This is how we designed our system. I'll go from the bottom, from the UI UX layer. There are 4 different buckets that we have. One related to detect bucket. So detect section, we'll have to look at the information from where exactly it is happening. From a data lifecycle, as James mentioned, if there is a telemetry informations that are defined in your equipment, that's the first data section. Then the second section would be when the customer is complaining about an issue. Customer may be calling tech support. Customer may be calling somebody to tell them that they have an issue on their equipment. That's the second level of data that you could get. Then there is an interaction between dealer versus customer through multiple channels, through chatter, through chat, or through phone calls, some type of a communication that happens between them. That's the second level. Then the third data section would be if it is covered, or the work order gets created for those issues, then the field service technician goes to the field and fixing those issues, and they are able to understand why this has happened and what causal part that got created because of this. That's the third data section. Then the fourth one would be the warranty claims. If there is warranty to be covered, then the OEM will look at those data, including images, including the 3 C's, causal and correction, and compliant, and all those information, and then adjudicate those claims. So those are all the information that we look at it in terms of the detect bucket, and we create the probabilities, and we create the ranking by looking at creating a failure cluster by combining the data that I talked about it. And we say that, okay, could be this because of this issue. This is the severity of number one, number two, number three. So let's take an example of an automotive. So if this particular issue belongs to an infotainment, then that cluster should go to, all these information should go to an infotainment department. If this issue belongs to, let's say, an chassis or an engineering department, who are responsible for product, it should go to them. So we create a cluster of multiple issues by analyzing these data. That's where the above section really comes in. We take the standard existing machine learning and statistical models, try to look at what is the probability of this could become a larger issue. What is the forecasted claims that could happen if this trend continues? What is the impact on my brand because of these issues? Those are all the good old analytics that we apply on top of the second layer. The top layer, which is the generative AI layer, after LLM came into our life, analyzing the unstructured data has become a lot more easier. With an NLP and looking at informations on your images, looking at informations on your audio logs has become a lot more easier. So we take the social media data, we take the customer call logs, we take all those informations and put the generative AI layer on top of that and create a cluster. So cluster is the primary functionality we provide for any quality team to look at it. And from the cluster, they can drill down in terms of what is the impact and what is the model. And the right side, that business values, that what you have is all that information that would be provided for an OEM to start analyzing this. Yeah, I'm happy to take up any questions on this slide, or maybe we have some more time we could allocate to start explaining some questions if there are any. Okay, let's go to the next slide, Pam. This is a failure cluster that I talked about it. In the screen, you're seeing 6 different issues. The first one, which is related to hydraulic system assembly. The way that we derive hydraulic system assembly anomaly is from those data sets that I talked about. It could be coming from the social media. It could be coming from the customer call logs. It could be coming from the repair order data. Our software should be able to group by different model, by series, by which causal part, and start identifying and mapping and enriching this data, because when we deal with this unstructured data, we have to enrich this data because most of the time we may not have a lot of quality data in here. So that's where the first cluster is getting created. Then these clusters will get moved from one bucket to another bucket. So when I detect this could be an issue, if I am an OEM, if the quality team or somebody who is looking at this application can push this into a investigate bucket. That's what you're seeing on the menu on the top. From an investigate bucket, it can go to a different group, different team inside. It could be an R&D team. It could be a battery-related team. It could be a team that is responsible for infotainment. They monitor the incoming information from them, and then they put a corrective actions. Then they put the right information back to how to prevent this. How do I control this? How do I put a recall? How do I do a service campaign for those issues? That's where those things get created, and then start monitoring these buckets. This is the simpler as we could build, and we have done this for a few of our customers here. Yeah, I'm happy to get into, if we meet in in our Map Connected session in October, I could explain in detail for if any prospects that are interested, or if you have any questions, please feel free to reach out to me on this topic. I'm happy to explain this. Yeah, so this is our cluster. This is our starting point to look at early warning. We try to provide the information as simple as this. There are some additional feedback that we received from our OEMs, and we are implementing that in order for them to understand, summarize it, provide more additional insights. We are thinking of providing that as well. I think we just have two more. Pam, can you go to the next slide? We'll just try to cover that, and then we can go into a question and answers. This is our standard project approach. I'm sure whoever has come to the Bridgestone event must have seen this. How we take that as an input data, how we define scope, how we put an outcome from the pilot that what we are proposing. I do not want to make it as sound like another salesy call on the side, but wanted to tell you guys that we are open for doing this. Let me know if anybody is interested. If not, we'll wanted to hear from your thoughts around how you are currently handling, or if you have any questions. Myself and James are here to answer some of those your questions. Any questions?
Yeah, this is Mike. The question always comes up. A lot of your examples, you had 100 cases, 100 claims. How can you determine if it's going to be a significant issue in the first 3 instances or 2 instances? Is there a severity that you apply? Is there a criticality? Is there, if it's safety, it flags at a much lower threshold?
Safety is one of the threshold. We have certain keywords that we look at when somebody is saying there is a fire, there is a broken XYZ, there is somebody got hurt. So we look at those type of comments. Safety is one of the priority. Ranking this priority is it's in itself is there are multiple parameters that we look at it. But looking at first 3 incidents, we may not be able to exactly say that, hey, this could be an issue. That's where we need a little more data, a little more information, and start looking at what exactly needs to happen. At least we need to start understanding and look at these issues for a week to make some meaningful insights. That's our insights so far. There are some incidents where people may say that, hey, if this is an IoT error event, this could potentially, can break. So IoT coding and IoT error logs can be another option, but I'm not sure how many equipment and how many, informations that you could derive from with a less amount of data.
Okay.
We probably have time for one, maybe 2 questions more. Or Pesci, did you have any questions for James?
Oh, yeah, I just have one question for James. James, you talked about finding your early warning from the first section. Can you outline what are your initiatives, or how are you thinking of doing it, or can you share your thoughts around that?
Yeah, sure. So we're used to dealing with data that is very, very, very precise, and we make decisions off that. We're not very good at looking at data that might be hinting at different things.
Okay, I think we want to segue now. Thank you, James and Pesci. Let's segue into, let's start talking about 12-volt battery digital signatures. And Tim from Toyota and Craig and Paul are going to introduce themselves and start their presentation. Go ahead.
Yeah, Pam, thanks for having us. For those of you that don't know, my name is Craig. I'm with Upstream. Paul is on the line with me as well. So I lead go-to-market activities here. Paul is one of the leaders in our customer success team. And the man of the hour, or the last half hour here, is Tim, who's a manager in the field operations team over at Toyota. So, folks, let's start with the problem statement. So, Tim, tell us what the problem is you're trying to solve.
Yeah, so sure. So, and thanks, Craig. I wouldn't go that far. I'd say I'd put the minute of the hour. We'll just we'll call it we'll take group effort there. But we talked about where could AI potentially take a role in helping one of our biggest problems or one of our challenges that we face every day. And I think across OEMs, and I've got a little bit of experience with some other OEMs, but right now I'm currently with Toyota and been for a while. And I think one of the things that we can always agree on is that battery replacement is one of the largest warranty claim volumes that we have across the board, right? It's also the most common part that we've had in vehicles since their inception. So there's quite a few things that from the warranty expense control side or the warranty expense side that we see is we see things from the entire life cycle. So one of the things that we talked about, I'd like to see where we could go with AI is how can it help our supply and demand? Could we utilize some AI utilizing weather information, weather patterns, or understanding dealer inventory levels from the supply side and the procurement side to drive, better predictive areas of supply. The other thing was invalid and inconsistent battery testing processes. Well, we have, in our case, we have 1,200 dealers across the nation. Well, each technician kind of has their own process, has their own environment that they survive in, and how is that applied consistently throughout each test to ensure that we have actually valid information coming in. And then we also have, with new connected technologies, what information do we have available? Could any of that be utilized to give us some indication that, batteries are not necessarily failing or on there or being predictive, but do we have some concerns that we could be feeding back to our R&D departments or our engineers that they could be utilizing to build a better battery, right? Or to build any progress to reduce any inconvenience to our customers out on the road, right? So those are the main three items that I think that areas where I think we could apply that. And I think I'm gonna pass it back to you and see where we can go from there.
Tim, thank you. So for those of you that don't know, Upstream started about 8 years ago with a single purpose, and that was to build a data analytics platform specifically for OEMs. We don't care if you're manufacturing a personal vehicle or a commercial vehicle or agri equipment. We built a platform that's been in production now for 8 years that collects all of those various data sources, which we can talk about in a little bit, and solve this problem. In fact, I know the purpose of this meeting was really to talk about what a POC would look like. In reality, we've gone beyond that, and we have this in production. So if anybody is interested in trying to figure out how they can get in front of and predict battery failures, give Paul and I a call or an email afterwards, and we can give you some very specific examples about that. And in fact, Mike, I'm glad you asked that question. And James, I love the challenge that you put out there a couple of minutes ago about being careful with predicting failures. Might be a little bit tougher on a tire because there's not the same level of telematics data available that we can see on a battery, but I think we'll be able to show you how we can predict those failures for you folks early, and hopefully not often, but at least early. So Nate, just real quick, where did this all come from, right? So a couple of years ago, actually 4 years ago now, McKinsey did some consulting work in the OEM space and determined that there was a way to proactively get in front of warranty issues, get in front of the claims that are coming in, and solve the challenge before it even became a warranty claim, right? So we definitely want to process warranty claims faster and cleaner and watch for fraud. Absolutely. But let's also step to the left of that a little bit and solve the quality issue early so that we don't have the claims coming out, claims hitting the warranty teams. So what you see here in blue is something that we started to work on back in 2023 with an OEM to build against their requirements and build against what McKinsey said to come up with this platform. And look, James actually presented something very similar for us like this just 20 minutes ago, right? What is the process that occurs when we're trying to figure out what the problem is? So Tim, I'm going to ask you to validate, right? Is this, at least at a high level, is this the typical process? And you're muted.
Never fails. I'm going to do that once. So yeah, this is definitely the typical process that I think we're all familiar with, right? But I think you've got one word in here that's pretty key, right? Which is reactive. And that's what, unfortunately, we are reactive in this entire process, because it isn't until the car is fixed and down the road before our engineers and our we have time to really dive in and understand what happened. And that's kind of what James was talking about with his process earlier, right?
So ineffective RCAs is a problem. It's reactive. Other challenges with, unhappy customers, et cetera. So you're saying you want to move to a proactive process.
Ideally, that would be great, right? That's what we all want.
So I am going to ask my buddy, Paul, to come in here. So for those of you that are interested, this process, which we laid out here with a pretty diagram from our marketing team, thank you very much. We're going to dive a little bit more into the technical aspects of that. So, Paul, help me out here.
Yeah, no, thanks.
Where do you want to go from here?
So effectively, I mean, maybe we just step back a little slide, but effectively, the investigation is starting too late, and we need to use data, right, to be a lot more proactive. So where can we do to enable us to do sort of the RCAs, the root cause analysis, much, much quicker? But what does that proactive data approach really mean, and what does it look like? So I like to sort of envisage, if you're out running, right, you're out for a jog, your foot hurts a little bit, or maybe your knee hurts a little bit. It doesn't stop you running. You typically, let's be stereotypical chaps, men, we typically ignore foot pain and keep plowing through it. But in reality, it probably means in 3-4 months' time, you're limping a lot. You may end up in the physio bench every week for 4 months. You've got patellar tendonitis or plantar fasciitis. This is equivalent to your car battery slowly losing charge over time, slowly degrading, and you really don't see that, right? You only notice symptoms of that when it's a bit too late, maybe dim headlights or it's slow to crank. Now step back and just go, it's got a little bit worse. Maybe you've gone out, not talking about myself, honest. Maybe you've gone out and done some hill sprints 5 miles from home. You've ignored that foot pain. You've actually compensated on your other leg. It's got a lot worse. Suddenly your Achilles tendon snaps. You now have to call roadside recovery in the form of the wife, otherwise known as Mrs. Mortimer, who at 10 o'clock is a little bit fed up with having to do this. In the UK, we use what 3 words as a location beacon a lot when you're in the middle of nowhere. Pretty sure the 3 words my wife heard was plonker, moron, and muppet. But this happens to vehicles as well, right? Your battery dies. What are you going to do? You've got to go through that roadside assistance call. And the goal for us is to move everything forwards using AI and machine learning. And if we fuel the Upstream platform with data, we can really enable that pre-claim detection when you have that foot pain and it starts to give you evidence that you're going to develop an injury later down the line. So before the customer headache. So we want your customer love department. That That's a term over here in the UK for a couple of OEMs, to not have such a big headache, right? So if we go to the next slide, Craig.
So,
You
so Paul, let me ask you a question here. So I love the analogy, but let me give you a real world example. My truck, I'm not going to name their brand, but the air suspension, I get a note about every 3 or 4 times when I turn the ignition on, service the air suspension. I ignore it because the check engine light doesn't stay on and is not blinking. So I figure, no big deal. Are you saying that with proper analytics on the back end, that could possibly point to an early indication that there's a issue there before it becomes a possible warranty claim?
Tim, do you want to give him a note to send him to the physio? Or
And it's not a
send
Toyota. I'll
his-
say that, it's not a Toyota.
Send his car to a
Well,
garage, because it strikes me that maybe he's ignoring that early warning system.
Yeah, because exactly, you're going to be in that situation that I was talking about, or I always end up in, right? The wife's at the grocery store in the middle of Texas summer and 90-degree heat, and the ice cream's melting, and kids are in the car. So if I had all that information ahead of time, I'm getting called those same words that Paul mentioned earlier, right? Because I didn't do anything about it. So yeah, I mean, you'd be in that same situation there, Craig.
Well,
Okay.
well done, chaps. The stereotype is alive and well. I'm pleased to hear it. So let's let's ignore the melting ice cream. But if you get 3 flavors, at least you've hit 3 of your nutrient values for the day, 3 of your fruit and vegetables. So Craig, if we focus on this car battery issue, what raw signals do you think might help with trend analytics to allow Tim or Tim's colleagues to do some sort of virtual inspection to prioritize your car, not the suspension, but the battery? What things do you reckon might be available remotely for vehicle telematics?
Okay, so Paul, I just acknowledge I ignore the warnings on the dashboard. And you're asking me that question. No, look, I'll say voltage, current. I don't know, maybe it's important, what happens when you turn the ignition on or off. You put me on the spot.
I'm glad someone paid attention at school. So, maybe 2 points to Hufflepuff for that one. Tim, help him out. As an expert in the field, what would you expect to get off a vehicle that might actually result in Craig not having to call his wife in a car park full of melting ice cream?
Back in the 60s and 70s, I'm sure that, yeah, definitely those were the core pieces. But I mean, nowadays we've got all kinds of things, right? We've got, how much amperage draws is happening during each frequency, or which in each sequence. I mean, you've got how much you've got onboard battery testing or how much cold cranking amperages are being pulled when it's actually started. How many times has it started? What's the temperature? What's the battery, or what's the temperature outside? What's the ambient temperature? What's the what's the battery temperature that side? What's the inside internal temperature of the vehicle versus what's the outside? There's all kinds of sensors that we have on the vehicle that do contain information that possibly could be utilized, right? So,
and that's a brilliant answer, Tim. So if you think about trend analytics, when we have the availability of those signals, ambient air temperature, the actual battery temperature, the battery voltage, the current draw, sorry, you're going to keep me honest here, the voltage drop on start, when it's cranking. Imagine comparing all of those signals across multiple rides. So you can go, we've had our first, and I forget the gentleman that asked the question earlier. I think it was it Michael?
Mike.
When you have the first 3 vehicles or the first 2 vehicles that come in and have had a battery replacement, we're ingesting the telematic data that Tim's just described for the duration of 30, 40, 50 journeys. And then suddenly you go, well, on the, what's the date today? On the 9th of September, Mike took his car into the garage. They replaced the battery. We could go, whoa, well, what was the battery health on the 7th, on the 6th, on the 15 journeys beforehand? And we can see the gradual decline in maybe voltage, or we can see the voltage increasing with temperature. We can also ingest those weather reports, Tim, as you mentioned. So we can see the ambient air temperature to say, you know, thankfully you guys weren't in the Portugal area with the wildfires this year. I'm sure you had plenty of your own. The ambient air temperature this summer, I mean, it was the hottest summer in Europe since 1976. So unless you're as old as Craig and ignoring the warning lights on your dashboard, that's pretty warm, right? So the trend analytics, one of our core capabilities, allows you to do early detection, pre-claim detection to say, there's something wrong with this. I can match that digital signature to those 3 vehicles that have come in, had batteries replaced. And now machine learning can go through your entire fleet, Tim, and go, here are the next 100 vehicles that are in the same place as ride 6 of Craig's car, or maybe Mike's car, before the battery got replaced at ride 15. So you can prioritize that replacement program, which should help you out with logistics quite hugely. Great. Do you want to just summarize the sort of the top 3 things that really proves that anatomy for warranty works?
Yeah, and folks, in all seriousness, what you're seeing here is what our customers have been telling us now for years, which is the ability to correlate across many different data sources. Sometimes it's static, sometimes it's streaming data. It could even be notes on a PDF that were written by a technician. That combined with the ability to put our purpose-built AI and ML, purpose-built for, you know, your industry, the ability to put that over top of it and then observe a digital twin, if you will, a live digital twin of the component, the 12-volt battery, or maybe a single vehicle. Maybe we're going to go a little bit beyond the 12-volt battery, or maybe a cohort or a fleet of vehicles. Again, the idea is that this system, let's call it a system in the back end, is continually digesting this data. There's a human in the loop, right? Somebody on Tim's team is in there. What about this? What about that? Let's look at this. Let's look at that. So every time there's interaction with the system by that person, that team, every time there's additional data being put in, it gets faster and faster and deeper into understanding what needs to happen. Did I pass the test ball?
I guess so for now. I'll let you off. You know, you are far too far away for me to really give you that much abuse. But I mean, when we think about the data sources we ingest, we are failing to ingest the contents of Tim's wife's boot. So we don't know that there is frozen ice cream in there or defrosting ice cream. I would imagine if it's defrosting, the kids are very happy. But we are looking at all of that vehicle data. We're looking at the warranty claim data coming from dealerships, regardless of language. You know, so this is where AI really steps up. You know, I know in the US, with your 1,200 dealerships across the US, I suspect you've got a common language. In Europe, we've probably got 18 different languages for an OEM like Tim's. And so the AI is taking the customer grumbling note, the symptom from the customer, hey, the vehicle's dead. The technical comments, we saw this DTC, we replaced this component. It's converting it to a single language, so it's really digestible to folks like Tim. And it's presenting everything in a highlighted manner. So these were the most common components of that complaint. These were the most common points replaced. These were the DTCs we saw, and we saw them in 90% of the cases. So it's a really powerful way of using AI to speed up that investigation. But when we ingest data, it's not just data from the vehicles, not just data from the dealerships, it's not just the repair orders. It can also be external data, such as the weather, such as the geography, such as what's the incline and location of these vehicles. So you can really pinpoint where they may have been. If you can just go on to the next slide, Craig, if you can, please. You know, and this really allows the digital signature of the vehicle to give you a very precise digital representation of that car, of that truck, for a point in time and all the previous points in time. So to Tim's point, you can see not just where the vehicle has shown, you know, 12-volt battery issues starting to creep in, but also is that a consequence of external factors like the weather? Do you have an annoying teenager? I have 3 that may be in the car when it's, you know, static, you know, draining it by charging umpteen. I mean, how many mobile devices does the average teenage girl need these days? My 3 daughters seem to have far too many between them. You know, so you're getting a lot of this data. So you can go, what was my voltage drop between journey end and journey start, you know, 2 hours later? What the heck? How come we've lost so much? So there's a lot of information we can get.
So, Paul, just looking at the time, I want to mention one thing here that Tim challenged us on previously, and that is PII. So can you touch on that, how we protect the customer's data?
Well, Tim, do you want to just
Yeah,
point out and challenge your issues?
yeah, Craig. So, yeah, Paul and Craig. So, yeah, you know, we're getting to the slide, and I keep seeing digital signature again. My challenge to you still is how our challenge is always going to be, how do we protect PII, personal information, right? Because customers have to consent to sending some of this information, and then how are we hiding that information or protecting the customer at that point in time? And that's going to be my biggest concern and challenge going through this, same as James with, you know, predicting. There's some definitely very, very tight ropes to climb there, right?
Yeah, and it's a great topic. I mean, data sovereignty in Europe is a big thing. You know, who do you have a data extradition treaty with? What are your regulations? GDPR generally, I can say freely as a UK citizen, GDPR generally scares the pants off anyone from the US. You know, what we need to remember is certain things are PII and certain things are not. So where we see PII, we encrypt them. And because we have come from a cyber background, actually we're a good position in that ecosystem, because where we see unencrypted PII, we can flag it and encrypt it for you. But you have full ownership of data sovereignty. None of your data leaves your environment. You know, we're not a solution where you're sending data to an external service. We install our solution into your environment, so you are very much in control of your data. So from a PII protection point of view, we encrypt anything from a display purpose that looks like PII, and if it's not encrypted, you know, we can let you know it's not encrypted. But it's a really important topic. I probably spent 47 minutes talking to an OEM in Japan, allowing them to have ease all of their concerns with regards to that exact same question, Tim, for operating across Europe. GDPR is probably one of the more stricter regulations in that area, but happy to have that conversation anytime. Probably need more than 5 minutes to go through it in depth, though. But it's a really great question, Tim. Thanks for raising it.
So we give you a screenshot here of what a dashboard looks like, but knowing that we only have 5 minutes left, Paul, do we want to open it up for questions?
Yeah, fire away. And of course, I've got my own questions to you, Craig, if no one's brave enough to come forward.
So let's open it up to the audience.
Maybe they like my dulcet tones so much they want me to carry on. I can't believe that's true, though. So, Tim, when you look at a dashboard like this and it's giving you repair orders by production month, what do you see this sort of that on the right-hand side? Where do you see the value in having an understanding of warranty claims and repair orders that are broken down by, you know, perhaps month in service, perhaps production month for a battery type issue? What does that lead you to sort of make conclusions or allow you to make conclusions on?
Well, that's kind of a loaded question there. I mean, me being the data analyst, I'm going to be wondering where most of this data is coming from to make sure it's validated. But I mean, really being able to understand where our dealers really is it moving more towards warranty based? Is that shift from warranty to customer pay to repair order? Is that being shifted? And they are all kinds of questions. It just right now on this level, it has the ability to open up different avenues and things to see. And I think that would have to be, unfortunately, boiled down into some more specific.
And that was such a really unfair
hang on a second, Paul.
question.
I want to touch on something that Tim said there, because I was just having this conversation yesterday with somebody else that, and I want to assure everybody here, right? Look, there's this immense amount of data that y'all are collecting. The question is, what's important? And our customer success team, Paul and others, would work with Tim or folks like Tim to help them understand, okay, if we analyze this set of data, what's the output and what impact can that have on us seeing an issue sooner than later? Okay, now what happens if we add this amount of data source, et cetera? So for example, this very battery digital signature that was created for the other another OEM, the question now is, wait a minute, okay, let's track what happens when it comes off the ship. Okay, not a problem, we can do that, but it's going to require them to take those vehicles out of transport mode, which is basically the battery's not doing anything, and if the battery's not on, the TCU is not transmitting any data. Okay, so the opportunity, or the test, if you will, that they are doing is, hey, let's pick some vehicles, let's put them in customer mode, or it's a mode that's between transport mode and customer mode. So there's a little bit of power being generated to now transmit more data around the battery and some of its systems while it's in transport. Oh, by the way, now let's keep that turned on when it's at the storage lot or at the dealership, and let's track to see if they're actually doing the PDI work that we're paying them to do. Because if they're not doing PDI on that vehicle, why are we paying them to do PDI? Why don't we collect the data to not have to spend millions of dollars a year to just, for PDI? So I say that to say, to Tim's point, right? And to what others may be thinking. You have to understand where the data is coming from. Tim's correct. Is it reliable data? Okay, once we validate it's reliable data, then we validate that the data is presenting a story that makes sense. And then what's the value of the story is telling? And then, okay, now that I'm getting value, what additional data sources can I add? And is collecting that additional data driving enough additional value to collect that data? So it's an iterative process that this platform enables you, your data analysts, your field quality inspectors, field quality managers, with help from us if you want it. It allows all that to happen. It's pretty exciting.
And I think the one thing too is, I don't know what I don't know. And to your guys' point, right? The purpose of this is to point out what I don't know. And so I see a lot of value there. That could be a lot of value.
Well, I think that means we are going to wrap up the presentations for today. That again was our 4th and 5th project roadmap from the AISWLM think tank. Tim, James, Upstream, and Tavant will all be there at the conference in October. So I hope that, as I mentioned earlier, we have planned events for interaction with our 5 AI project roadmaps, as well as the other AI service providers that have been involved in this group. And just a reminder, we now have 5 project roadmaps. The roadmaps are all worked out. They just need someone or multiple people to work with us and get some of these free POCs going. So hope to see you all in October. If you haven't bought your tickets yet, by September 26th is the last time that there's a little discount on the tickets.